Proxima b, orbiting the closest star to our solar system, has long fascinated scientists and dreamers alike. While its sunlit side has received substantial attention and study, its dark side, permanently cloaked in shadow, remained a mystery. Now, recent revelations from the James Space Telescope have begun to unveil the secrets of this enigmatic region. The newly obtained data has left the scientific community in awe, raising more questions than answers. Proxima b is a tidally locked planet, meaning one hemisphere perpetually faces its star, bathed in endless sunlight, while the other remains in eternal darkness. The assumption has always been that the dark side is lifeless and frozen. However, classified images and readings tell a different story. The first hints came as faint but persistent signals, strange emissions from the planet's night side. These emissions, including infrared radiation and structured energy patterns, defy our expectations and hint at localized sources of heat and light. The unexpected nature of these signals challenges our understanding of planetary environments. Natural geological explanations, such as volcanism, have been considered, but they don't fully account for the complexity and regularity of the emissions. The possibility of artificial origins has entered serious scientific discussion. Could the dark side of Proxima b conceal advanced technology? If these emissions are not natural, they could indicate the existence of a civilization thriving in conditions thought inhospitable for life. The structure and regularity of the emissions are key factors in this speculation. They resemble patterns similar to urban lighting as observed on Earth, organized, grid-like, and seemingly deliberate. If true, it suggests a society that has not only adapted to a harsh, sunless world but has engineered solutions to make it habitable. This would require a level of technological sophistication far beyond our current capabilities. Heat and light would have to be artificially generated, likely using geothermal, nuclear, or other exotic energy sources. Proxima b's tidal locking creates two extremes. One hemisphere scorched by constant sunlight, and the other plunged into a frigid, sunless abyss. But what if the dark side isn't just a frozen desert? What if it houses structures, maybe even cities, powered by sources we can't yet comprehend? The James Space Telescope detected unusual magnetic fluctuations on the dark side. These anomalies hinted at large-scale electromagnetic activity, possibly generated by machinery or power grids. Accompanying the energy signatures were rhythmic pulses, almost like coded transmissions, frequencies not observed in nature. Further investigation revealed an even more astonishing clue: subtle light emissions that appeared to follow a pattern, synchronized across vast distances. These weren't random flashes. They pulsed in cycles, forming geometric arrangements. When scientists adjusted the images into different spectrums, these lights formed a lattice-like grid extending for hundreds of kilometers. It gave the impression of a sprawling megastructure or network, concealed beneath the planet's freezing veil. What's more chilling is that this pattern seems to respond to incoming electromagnetic waves. When certain frequencies were directed toward Proxima b, a slight shift in the return signals was observed, almost like an echo that changes tone depending on the pitch of the initial sound. This interactive behavior sparked speculation that some kind of intelligence, or at least an automated system, could be present. Among the most debated findings is the discovery of surface distortions in the shadowed hemisphere, anomalies resembling artificial formations. These include long, linear ridges, rectangular depressions, and dome-like protrusions. They could be geological, but their symmetry and alignment strongly hint at construction. The geological makeup of Proxima b doesn't explain the material consistency or uniform heat distribution around these anomalies. It's as if they are made of alloys or substances engineered to retain warmth, even without sunlight. The data has forced many scientists to reconsider the possibilities of habitability in low light or no light conditions. If life exists on Proxima b, especially on its dark side, it must have adapted in extraordinary ways. Photosynthesis as we know it wouldn't work without sunlight, so organisms would have to rely on chemosynthesis, like some creatures on Earth's ocean floor, near hydrothermal vents. But a leap to a technologically advanced society existing in such conditions raises profound questions about the nature of life, intelligence, and survival. The signals from the dark side have also prompted comparisons to early SETI observations, the search for extraterrestrial intelligence. Some researchers have noted the eerie resemblance between the Proxima b pulses and the famous "wow" signal detected in 1977. Although that signal lasted only 72 seconds, the Proxima emissions have been recurring, stable, and precisely timed. They're not just bursts of energy, they seem to hold structure. Could this be a form of communication? A few daring theorists have proposed that the civilization, if it exists, is intentionally hiding on the dark side, perhaps even aware of Earth. If a species can manipulate energy in complete darkness, harness complex electromagnetic fields, and construct massive heat-retaining structures, they might be capable of interstellar surveillance. The question then becomes, have they seen us? Are we the ones being studied now? Some propose a more alarming theory, that Proxima b was once like Earth, with an atmosphere and balanced rotation, but something happened. Perhaps a war or a natural cataclysm forced its inhabitants underground or into the shadows. The structures and energy fields we observe could be remnants of a once thriving civilization now surviving under extreme constraints. The dark side might not be just a choice, it could be the last refuge. Others argue that we're seeing the work of automated machines, AI systems left running long after biological life ended. That would explain the pattern of emissions and the lack of clear communication. Machines might still maintain energy levels, repair infrastructure, or continue some forgotten mission. It echoes science fiction, but the data forces us to ask, are we looking at the ruins of something grander than we can imagine? One critical moment in this investigation came when the James telescope focused its lens on a particular region showing high activity. The region, nicknamed the Ma, emitted a unique signature, far more intense and varied than the rest. It pulsed with multi-spectrum radiation and even released short bursts of what resembled Morse code-like intervals. An attempt was made to reply using a laser communication system. Strangely, 29 hours later, a new pulse returned, matching the Earth signal in rhythm but not in language. It wasn't a clear reply, but it was a reaction. This led to the launch of Project Echo Drift, a joint mission involving multiple space agencies aiming to further probe the planet using remote drones and AI-moderated data relays. The challenge lies in distance and transmission delay, over 4 years one way. But the drive to understand what lies hidden on the dark side of our nearest neighbor has never been stronger. Amid all this, some urge caution. What if the emissions are warnings rather than invitations? What if our presence is being detected, and not welcomed? The dark side of Proxima b could harbor secrets that humanity is not yet prepared to understand. There are even reports, though unverified, of a repeating frequency pattern that loosely resembles known mathematical constants. It could be random, but it might be a universal language, a key waiting to be decoded. The mystery of Proxima b's dark side pulls at the boundaries of science, imagination, and fear. Are we alone? Or are we being watched by something just out of reach, hidden in shadow, yet capable of reaching across the stars? The implications are staggering. If intelligent life exists in the darkness of Proxima b, it rewrites the rules of biology, astronomy, and perhaps even philosophy. Whatever the truth may be, one thing is certain: the dark side of Proxima b is no longer silent. It whispers through signals, pulses, and strange lights. It challenges us to look deeper and listen harder. As the data streams in and theories multiply, humanity stands on the edge of a revelation that could change everything we thought we knew about the universe. The darkness of Proxima b is not an absence, it might be a presence. One waiting to be understood. One that could redefine our place in the cosmos forever. This is Discovery at 2.0. Stay curious.